Welcome back to Random Object Review. Today I have a set of three things. I have three element cubes consisting of three individual elements, and I had these a while ago, so I remembered I had them, and I'm like, okay, I'm gonna make a video on these. Review-wise, I think these are from a website called Luciteria.com or something like that, where they sell pure element cubes. I gotta say, these are pretty nice, because the thing is that it perfectly shows you how different elements have their different weights, different properties. See, for example, you have carbon here. Now, this little thing of carbon weighs around 30-something grams. This cube of tungsten weighs around 300-something grams. So it weighs a lot more, around it's a little less than 10 times the weight, I believe. And I have one that's right in the middle, where it's bismuth, and tungsten is, number 74 on the periodic table, though bismuth is 83. But bismuth weighs less, tungsten weighs more, you get the gist of it. It's different densities. Let me give you a little science lesson here. So the density of carbon is about 2.26 grams per cubic centimeter, while tungsten's is a whopping 19.25 grams per cubic centimeter, meaning that it weighs a lot more in the same amount of, space. And the calculation is that when you drop this cube of carbon and drop the cube of tungsten from about 2 inches high and landing on a little table, the impact force of the carbon is about 0.018 joules of energy, while the tungsten's is 0.15 joules of energy. And, it's like 10 times the energy, while, they fall at the exact same rate, but the only thing that the tungsten cube has more of is impact energy when it falls. See, if you see this, they fall at the same exact speed. They hit at the exact same time. You could, if you dropped, for example, a feather in a vacuum chamber and say, I don't know, a block of steel, they would land at the ground at the exact same time. The only thing you'd have more of is just energy of impact in the steel, while the feather would still fall at the exact same time. I can actually show you a cool example that's outside of a vacuum chamber that can do the same thing with a piece of paper. So, for example, grab a book or some heavy object that has a bigger area than the paper. I grab the toolbox here, and the thing is that the air resistance on the toolbox is a lot less because it's a lot heavier and it's a lot larger. So it takes all the air resistance while the paper falls on top of it. So when you drop it, paper falls exactly the same rate as the toolbox. So that's one way to show you that, paper falls the exact same rate as everything else, just the air blocks it, so it takes a lot longer to hit the ground. But I know what you're gonna say. That's simple science. That's just simple stuff. I agree with you. But the thing that I find really, really cool about these cubes and everything is just the fact at how much more this weighs than this. Than the carbon. So for an example, if I were to take this and say throw it at a wall, right? If I were to throw it at a wall, it would most likely probably chip the paint, but this thing would probably take damage and fall to the ground. It might have a scratch in it, or it might even chip off some of the carbon. But tungsten, on the other hand, is one of the hardest elements that naturally made. So if I were to take this and throw it at that wall, it would not only hit the wall and not be damaged, but it would go here, through the wall, through the other side of the wall, and probably around into the other wall if I threw it hard enough. See, if I were to throw it straight, this way, like that, it would most likely go through the both walls. That's how dense this thing is. That's why tungsten is my favorite element, because it's so ridiculously heavy for its size, and considering the fact that it's it's not cheap per se, but it's definitely the cheapest metal that you can buy that is dense to the point where you'd have something like that. The only things that are really dense are iridium and osmium, which, a cube of osmium of that size would probably be 10 grand or something, a ridiculous number like that. So considering that one was less than $50, I'd say that's probably a win. Now you might have noticed that I actually had another cube there, a third one. It was bismuth, and bismuth is also one of my favorite elements because it can make one of the coolest looking crystals that I've ever seen in a metal. And what happens is, under certain conditions, you can actually I think you can make them in your house with a stove and a pot that you really don't want anymore, and a couple bars of bismuth. But you take it, and what happens is you melt the bismuth down in the, pot at one of the highest settings, because it has a relatively low melting point. And the bismuth will melt, and after a couple minutes, the surface will solidify, and after that, you can take little pieces off the surface, and you will get you'll at first have a solid block of bismuth, but then afterwards, you'll come up with something like this. This is called rainbow bismuth, but it's basically the literal exact same thing as the bismuth cube here. And it was, that one was, I think, grown in a lab in Germany, last I remember when I ended up getting the thing. It was, and like, the thing is that bismuth is really cheap. I think it's like, you can probably buy a bar that's a kilogram for maybe $30. It's not that expensive. It's literally one of the main ingredients in Pepto-Bismol, so you can tell that it's definitely not a rare element. Regardless, yeah, considering this is a random object review, and this is like the third episode, I don't really pay attention to these, but I'd rate these 10 out of 10 because they're pretty cool. I will say they're probably some of the coolest things I think I have, because I really, really like the periodic table and all that. Just fun stuff to learn about, But that about does it. Hope you learned something there. Have a good day.